Good day to everyone. My name is Princess I. C. Disponte, a member of Group 1, and we are here to report to you this case study on the initial traffic assessment on the intersection of G.S. Toralba Street and Celestino Gallaris Street.
Hi, this is Mac Walter Alboruto, and I'll be discussing to you the land use and physical conditions and traffic conditions and behavior at Celestino Gallaris and G.S. Toralba intersection at Gallaris City. So the first one is the land use and physical conditions. The area surrounding the intersection reflects a mixed land use pattern with residential buildings, commercial establishments, and educational institutions all in close proximity. This naturally results in high pedestrian volumes, especially during morning and afternoon peak hours, and also the mass times. However, pedestrian infrastructure is grossly inadequate. Sidewalks are either too narrow, poorly maintained, or completely missing in certain areas, forcing people to walk on the roadside amidst heavy vehicles. Further compounding safety concerns is the presence of vegetation and informal structures near corners. This partially obstructs sightlines. These obstructions reduce the visibility of oncoming traffic, posing risks to both drivers and pedestrians. The drainage system was not clearly visible during the dry weather observation, but existing surface wear suggests that water damage and pooling may occur during rainfall, potentially worsening road conditions. Next one is the traffic conditions and behavior. So the traffic at the intersection was characterized by moderately heavy flow dominated by motorcycles, tricycles, and private vehicles. The absence of lane markings or sign results in vehicles merging and turning erratically, with no uniform pattern of movement. Turning, especially at tight corners, is inefficient and sometimes hazardous due to limited space and lack of guidance infrastructure. Informal loading and unloading zones were also observed. Tricycles and motorcycles often stop at a curbside or even within active lanes to drop off or pick up passengers. This practice partially obstructs the roads, slows traffic, and increases the likelihood of collisions or congestions. The lack of enforcement or any traffic calming measures, such as speed humps, designated bays, or bollards, allows this behavior to continue unchecked.
First one is no traffic enforcer present lang. Bisan bitaw daghan na kayo ang mga sakyanan nga labay adto ang gihapoy traffic enforcer bitaw nga present at nga time. Then the second one is rely on driver discretion. So akani nay kasagaran dinhi is mga tricycle driver kay kanang may pasahero sa pikas palit ra sila og U-turn bitaw kay kuan para makasakay ko dyan. Then the third one is dominated by motorcycle and tricycle. So sa among traffic count mao jud ni kanadaghanan nga manglabay atong area basta ingat mga oras. Then the fourth one is informal loading and unloading. So ang tricycle driver would ang kadaghanan din ni makuha kay kanang mukalit ka bitaw sila gunong basta ni pasahero dyan makapos naman sa traffic atong area. Then sa engineering, no traffic control atong area nga kuan among may giobserbahan kuan kanang wa gid si traffic light, wa si mga signs, ang pavement markings pud is di na kayo makita dyan makapukos dyan ang confusion sa mga kuan kana sana mga gihay bitaw nga mga tours ay kanang mga tricycle drivers ano. Then the second one is poor road design. So kani di organize lang flow sa ilang traffic kanang flow sa ilang road kay lagi mga markings niya is kuan na di na kayo maklaro. Then the third one is tight turning radius. So ato pud nga time namin na obserbahan nga katong na delivery truck bitaw diyan gikan siya sa Celestino Gallaris Street diyan i-left turn siya og left turn niya nakapos naman siya traffic kay tungod sa kagamay ra ang road bitaw dito nga area diyan kuan dako siya nga sakyanan ni kuan ni left turn mo to diyan. The fourth one is worn pavement. So ato makita na ang mga pothole mga cracks na sa kalsada diyan makapos diyan na siya og nang kuan nga mga traffic siya nga na. Then the fifth one is no pedestrian crossing. So bisan bitaw kanang daghan na kayo mga tao dito wag ito si pedestrian crossing nga makita bitaw dito nga time.
Hi everyone, my name is Shatsin Coley Bongar and I'll be the one to present to you our traffic data collection. First, we have here the method of data gathering. The traffic data was collected through a manual traffic count conducted at the intersection of the G.S. Toralba Street and the C. Gallaris Street. The activity was carried out on March 21, 2025 from 7 a.m. to 8 a.m. So as you all notice, it happened during peak hours because we wanted to witness a realistic idea of the traffic flow in that certain area. So since it's a three-legged intersection, we strategically positioned each group at designated points indicated by the blue arrows. So each member was assigned to count a specific type of vehicle. The second one, we have here the observations during data gathering. During the observation period, we noticed is the high volume of motorcycle, tricycle, and cars that passes through this intersection. Its volume keeps increasing as time goes by. So this is consistent with the typical commuting pattern in the area where motorcycles and tricycles are the most common mode of transportation. So the traffic flow in that area was generally steady with minimal congestion, although brief build-ups at the stoplights. Now we have here the traffic manual count data sheets and summary. All road traffic count data collected during the manual traffic count are presented here. This includes the manual tally sheets that we used, as well as a summary table showing the total counts of vehicles passed on the intersection. So here is the summary. It shows that it was conducted on March 21, Friday, 7 a.m. to 8 a.m. at the intersection of the J.S. Turalba Street and the Sigayara Street. We have here the car, jeep, vans, and SUV, a total of 146, 566 motorcycle, 170 tricycle, 1 taxi, 2 jeepney or the multi-cab, 33 delivery goods, 1 JT Express, 0 small bus, 0 large bus, 5 2-axle trucks, 0 3-axle truck, 0 4-axle truck, 0 5-axle truck, 0 4-axle trailer truck, and 0 5-axle trailer truck. So the last part of this traffic data collection is the documentation. So we insert the photos there that shows the current situation of the area during our manual traffic data collection. Thank you.
Hi, my name is Juman Bernard. Now we're gonna discuss about traffic impact assessment. Hi, my name is Juman. In order to find annual average daily traffic and level service, we first tallied data from our previous survey, and with the given past data, we chose the same date of the survey, which is on Friday. With the past data, we find the hourly expansion factor and daily expansion factor. Then with that, we find the annual average daily traffic is just equal to the sum of the vehicle multiplied by its hourly expansion factor and daily expansion factor. Then we multiply it by the seasonal factor, which is just 1, since the Philippines has only wet and dry season. We find that the ADT of the vehicle, car, jeep, van, and SUV is equal to 145, while motorcycle is just 555, tricycle equal to 1, jeepney equal to 2, delivery goods equal to 31, GT Express equal to 1, truck with 2 axles is just equal to 6. And with other vehicles that I didn't mention is 0, since we didn't see any vehicle that's such type driving by the intersection. Now, since we have the ADT of the vehicle, we convert them with the respective PCU, which give us the total sum of 2014.15. Now we have our ADT. Now we're gonna find the level of service. To find the level of service, we first find the volume capacity ratio, which is just multiplying the total sum of ADT in PCU multiplied by peak hour, which is 8%, divided by basic hourly capacity. Since we don't have basic hourly capacity, we first find it by the width of the carriage width of the road, which is just 2.5 meters. Since the road has 2 lanes, we determine the total carriage width is 5 meters, located in the urban area. And with utilizing the table given, we determine that basic hourly capacity is just equal to 1,200. Now, the volume capacity ratio is equal to our ADT in PCU, 2014.50, multiplied by our peak hour factor, 0.08, divided by our basic hourly capacity, 1,200, which give us to 0.13. In level of service, anything less than 0.20 is anything less than.
Hi, I'm Luis Angelique Manta, and I am here to report the level of service. It is determined that the level of service at the intersection of Turalba Street and Gallardo Street at around 7 to 8 in the morning is A. It explains that traffic is smooth with little to no congestion, and it is not that much of delay within the peak hours during the time of observation. There are also signs that contribute to the result. For example of that is the truck ban. Trucks are banned passing the intersection at around 7 in the morning until 7 in the evening.
Hello everyone and good day. My name is Jerasami C. I'll be your reporter on recommendation on our case study. Hello everyone. The student of Transportation Engineering course recommends installing a no loading and unloading sign on 003 Celestino Gallery Street near the intersection to prevent vehicle delay at this busy junction near the cathedral. A major landmark with high public transport volume, this aligns with the best practice to reduce roadside obstruction and improve traffic flow and safety. We also suggest a no left turn sign facing the cathedral to reduce congestion caused by left turning vehicles, directing them to use alternative right side road at the same destination, enhancing intersection capacity. Additionally, we recommend adding clearly marked crosswalk and pedestrian signal to improve pedestrian safety and coordinate traffic movements, given the heavy foot traffic near at the cathedral and commercial areas. This measure will promote safer and efficient traffic operation at this critical intersection.